Good morning, students. In the last lecture, I was explaining you about the general plane motion and the method to find out the velocities at each point in a general plane motion. Now, what do you mean by a general plane motion? A body is moving in translation as well as in rotational motion, right? So, if suppose in that case we concluded that the total velocity at any point, say the velocity at this point, which is rotating as well as it is translating, so the velocity at this point will be a sum of rotational motion as well as translation motion. Now we are going to solve the same problems, same sort of problems, such that this motion, which is translation as well as a rotation, this is taken as a pure rotation motion with respect to a point, and that point is called as instantaneous center. Okay, so generally I assume that this material is moving from here, this point to this point, and then it is making a turn. Okay, if suppose I am considering this example, instead of moving straight and making a turn, I am going to consider that this motion is off from this point, from initial point to a final point here. That is, here you are considering a pure rotation of this object with respect to a point, and this point is called as instantaneous center. Okay, now how will you find this instantaneous center? It is simple, and this method is very simple. You can do the problems that we have done in the last lecture by this method also, which will be more simpler than that we have done. Okay, the general plane motion, that is motion of rotation and translation body at a given instant, can be considered to be that of pure rotation of a body about a point. Okay, this point about which body can be assumed to be rotating at a given instant is called instantaneous center of rotation. Now, I told that instead of this body is moving from here to this point, I am considering this total as a pure rotation motion with respect to a point, and this is your instantaneous center. So here the velocity at this point at given instant is 0. This point is called instantaneous center of zero velocity. This point is not a fixed point, and when body changes its position of instantaneous center also changes. As soon as the body changes its position, if here you have a velocity at this point, velocity along this direction, and here it's along this direction. If you change this, that center may be shifted. Okay. Now how will you locate an instantaneous center? Consider a body AB in which A is having velocity VA and B having VB. See, you have a velocity. Consider this object AB, and the part A is having a velocity along this direction and B is having a velocity along this direction. So simply you just need to draw two perpendicular lines for velocities of A and velocities of B. Okay. Now the point at which this perpendicular lines meet is called as instantaneous center of rotation. That's all. You draw perpendicular to the two velocities, and the point at which they meet is called as instantaneous center. So with this as center, this body will be rotating. Body will experience a pure rotation. IA and IB are lines joining the points of velocity VA and VB respectively. So what happens initially for general plane motion, VA is considered as VB plus VAB, something like that, right? Now here we have general plane motion, translation motion as well as rotational motion in this case. Okay, now so in the previous case, now here since we are having a pure rotation case, for pure rotation the velocity will be r into omega. Here instead of r, what is your r? Say here VA is equal to IA into omega and VB is equal to IB into omega. That's all. Okay, now we'll see that in the properties of instantaneous center. The magnitude of velocity of any point on a body is proportional to its distance from instantaneous center and is equal to angular velocity times the distance. Okay, so magnitude of velocity at any point, say this is VA at point A, magnitude of velocity is VA on a body is proportional to, it is proportional to distance from instantaneous center. Distance from instantaneous center is IA and is equal to angular velocity times the distance. Okay, angular velocity times, that means IA into omega. For B it is IB into omega. You know how this came? This is considered as pure rotation, so r omega. Instead of r, you have the radius is from instantaneous center, that is IA and IB. Okay, the direction of velocity of any point on a body is perpendicular to line joining that point and the instantaneous center. Okay, that I have already told. Okay, so we'll see some more cases of locating instantaneous centers. Okay, case 1. When direction of velocities of any 2 points of a body are known. In this case, point of intersection of lines drawn perpendicular, direction of velocity will be instantaneous center. See, the same principle, VB, you are having a velocity VB, VA, you join this by plotting perpendiculars. Meet at a point, that is instantaneous center. Now, next case is when direction of velocities are parallel, magnitudes are equal. Here the point of intersection of line joining the tip of velocity vectors and either the line joining or extension of line joining the points will be the instantaneous center. See, if you are having velocities which are parallel, VB is in this direction, the parallel vector is VA. Then what you need to do is that you extend this line and join these vector components and mark a center I and make them to meet at this point and provide this distance as x, which will be found from the problems. Okay, now if they are in parallel but opposite in direction, then VA is in this along this direction, VB join this, that's all. So this second case is very important. Okay, this is not going for perpendicular lines. Already there is perpendicular line, this one and this one is perpendicular line. You need to join those two vectors, direction of vectors. Those vectors are joined. Now another important case, the point from which body is rotating is simply called instantaneous center. So a body which is rotating with respect to a point. So if you consider a disk which is rotating like this and which is moving like this, you can say that at this point with respect to this point the object is rotating, and again if it is placed here with respect to this point, this is rotating. So instantaneous center will be this point. Okay, so body A rotates with respect to point A. Oh, this is another important concept that you should understand. Okay, so we'll do problems regarding this. The same problem we have done in the general plane motion first method. We are doing it with respect to or with the help of instantaneous center method. A cylinder of radius 1 meter rolls without slipping along a horizontal plane AB. Its center has a uniform velocity of 20 meter per second. Find the velocities of the points D and E on circumference of cylinder as shown. Okay, so the same problem we have done in another method, right? Now here you need to find out, it is very simple, find out the velocities at D and E. So what you need to do, which is the instantaneous center here? O, because this is rotating with respect to point O. So you join DO and OE. So velocity at E will be OE into omega, and velocity of D will be OD into omega. That's all. You are done with the answer. See, radius is given, VC is given as 20 meter per second, VD and VE you need to find out. Since the body moves on plane AB with respect to point O, O is the instantaneous center point. VE is equal to OE into omega and VD is equal to OD into omega. So for that, first of all, you need to find out omega. So VC is equal to R omega, right? At center point, this is radius into omega. Radius is 1 into omega, which is 20 radian per second. Okay, now VE is VE. VE means instantaneous center is this one, OE into omega. So OE is 2 into 20. Now VD is here OD into omega. OD is this distance into distance. 1 plus 1 square plus 1 square will be OD square. OD is root of 1 square plus 1 square, 20 root 2 VD you got. So this answer will be same as that we have solved in our last session. So both will be having the same answer. We'll do one more problem. A bar AB rests at edge of a wall of height 3 meter at some point C on the bar as shown. The bar makes an angle of 60 degree with the horizontal. If end A moves with a constant velocity of 6 meter per second, find angular velocity of the bar. Okay, they have given the diagram. So there is a bar here. So this A, I am pulling this in this direction and it is going with a velocity 6 meter per second. So what happens if I pull this? This will move in this direction, right? So at point C there will be a velocity VC. Okay. Now what do you need? So you got two velocities, that is VC and VA. Plot the instantaneous center. Okay, that's all. This is I, this is A, this is C. Okay, draw perpendicular, then you will get C. With point C, you draw a perpendicular. A, you draw a perpendicular. Then the question is simple. You need to find out IA and IC. You know VC is equal to IC into, VC is IC into omega and VA is equal to IA into omega, where you know VA. Okay, now from geometry you can see distance. That means here they have given 3 meter and this angle is given as 60 degree. So sin 60 is 3 by CA. You got CA as 3.46. So from you take next triangle. Okay, 3.46 is this side. This angle will be 60y. Since this is 60, the rest of the angle, this will be 30 degree, right? So 3.46, then cos 30 is 3.46 by IA. IA is equal to 4. IA, you substitute in this equation, IA into omega, you get VA. Omega as 1.5 radian per second. Okay. Okay, we'll do some more problems regarding this in the next lecture.